So they let this. Okay. So this is the men's room. And what happened was that the security came, they took them out of the men's room and they kicked them not only from the men's room, but also from the whole concert. And then they went to the Twitter, they started to share their story, and everyone started saying how unfair this experience is. And this experience is not only, sorry. Okay, sorry for that. So, I explained this experience is not exclusive to this concert, and Insider has reported that the experience that women experience much longer wait time in front of compared to the main counterpart is goes up to 34 times more for women to wait in lines compared to men. So, and also for LGBT plus individuals, they do not use either of these gender-segregated restrooms because there has been a lot of reports on harassment, verbal harassment, or physical harassment for these individuals, making them uncomfortable to use restrooms as well. So the main question of this paper that I'm presenting today is that how we can ultimately renovate the current spaces that we have in order to provide potty parity, which means the equal access to restroom for all individuals. So before going to explain what we did, let me go over the literature. So because of the waiting time component in our model, we're related to the literature on strategic customers in the treatment system, and this literature is huge. There's a lot of great works in this literature that they measure the performance of the system by considering the efficiency and wait time in the system. However, what we do is that we're measuring the performance of the system from current measurements, and also we add some components in the modeling that I'm going to go over. And also because we're going to use the concept of unisex restroom, which allows every individual to be able to use the same standard, we're related to the literature on process flexibility. So in operations management, the best, the most exciting result on process flexibility is that we appreciate a fully flexible system. However, the appreciated result is that by limited flexibility, you can capture most of the benefits of a fully flexible system, which is the result that people try to say in most of the settings, we can get that. So this, I want you to know that this same result has been developed in a manufacturing setting, and I'm going to say what are the tools when we apply this concept in a social setting. And the third stream of literature that is related to us is about works on potty parity that they mostly use numerical study in order to provide guidance for the practitioners and the policymakers. However, here we're going to focus on a theoretical analytical work in order to provide more insights in a concrete action for practitioners. And at the end, we're related to the discussions and operations management on Earth.
Where's the Princess Bridge Club room?
Right. So we're also related to the first measurements in operations management that are mostly used Rawlsian principle. And here we're also going to consider distributed fairness as well. So I'm gonna explain each component further. So what we're going to do in this paper is that we're going to define a utility function for each of the individuals using restrooms. So often using a restroom, individuals get some reward for using a restroom, minus they incur some this utility by waiting in a line, minus some this utility because of the mismatch between the gender identity and the type of the restroom that they attend, minus some this utility for the type of other people who are going to use the same space as they are, that we forming other safety concerns that people have. Now let me tell you how we're going to model each of these components again. So imagine that we have only gender-segregated restrooms, so we can consider that we have two classes of customers. One of them are going to use the women's room, and the other is going to use the men's room. And once, and we're going to model it as an LGBTQ. to capture the expected wait time of individuals in the restroom line. And once we have a unisex restroom, then we have a spillover of individuals from each of these gender-segregated restrooms to the unisex restroom. So we're going to model the expected wait time of these individuals with an LGBTQ with two classes of customers. Now, how we're going to consider the gender identity, we consider that preference for individuals in each of these classes for using each of these restrooms is heterogeneous. So we map each of these class of customers on a hosting line between the gender-segregated restroom and the unisex restroom. So an individual with type V0 is going to incur V0 times T cost for using the gender-segregated restroom and 1 minus V0 times T for using the unisex restroom. So here T is the sensitivity of the population to the notion of gender identity. And also, we do not consider any specific distribution of gender types because we assume and our model works for any type of gender distribution over preference of individuals. And now how we're going to model the safety concern, we're saying that individual safety concern increases if the type they have, the difference between my type and the other people who are using the restroom is going to increase. So if when the heterogeneity in the group and people are using the same restroom increases, then individuals are going to incur higher safety concern. So here, if the highest and lowest type are denoted as V bar and V lower bar to use the restroom, the maximum of V0 minus V underline and V0 minus V overline are going to show how much safety concerns I have. And also if like the people can be from the other line. Now, if we solve this model and consider it for each layout of the restroom, we're going to consider that individuals go to the space that maximizes their utility, and then we're going to compare different performance of the system in different layouts at the equilibrium. Now consider the current state, which is we have only gender-segregated restrooms and women spend longer time in queue compared to men. We're going to measure the performance of the system by considering the total utility of individuals as a measurement of the efficiency in the system. And for purpose, we're going to consider what is the minimum utility gain in the whole system and what is the difference between the maximum and minimum utility gain in the system. One solution, viable solutions that is adopted heavily in Canada is that let's put all the restrooms together and build an all-unisex restroom. So it is great because once you pull all the servers together, you have operational efficiency there. So that's great. Also, you have full flexibility because you made everything unisex. So operational management against this is great. And also, all the individuals are going to spend in the same line. So it's also perfect. However, once we measure, we actually calculate these measurements, we see that you will save in all these measurements. However, if you were only converting one unit of the main restroom to unisex, you would have seen you have improvement in all these measurements. So what we conclude here is that a little bit flexibility here actually makes the full flexible system. And why is that the case? Because as I told you, this concept of fully flexibility has developed in manufacturing setting. So that's great. You can put all the parts to be processed with one machine. However, once you bring it to the social concept and put all people in the same group, then they start having this belt, what is here, what is here, and then have all these safety concerns and have the general identity of customers that makes the system to actually fail. So here is the main result of the paper. And then for those of you who are questioning what happened to the wait times of this restroom, what we showed is that actually the difference between the wait time of the women's restroom minus the men's restroom is actually dropping, or everyone is going to enjoy higher utility, and both results are correct. Now that we established that conceptually, in order to provide efficiency and fairness, we need all three types of restroom, and we cannot eliminate any of these restroom types. To achieve this result, we provide an algorithm that is simple and also interpretable for the practitioners in order to understand for their own space how many units of restroom for each of these types they need to provide in order to ultimately reach the result that they want. And then also, as I mentioned, we established other benefits that unisex restroom can bring to the table. For instance, in a model school, I just consider that we have individuals going to the restroom. However, you can have fluctuating arrival rates of different genders to the restroom while at time. For instance, if you have only 4 women's room and 4 men's room, once you have a lot of men coming to the to use your facility, you have 4 restrooms idle because they cannot use the women's restroom. And vice versa, when you have a lot of women attending your facility, then you have 4 restrooms of men that are idle. However, what we show is that having unisex restroom is naturally controlling for your congestion when you have a fluctuating arrival rates of different genders and demographics into your system. And also, we measure the inclusivity of the system once we assume that individuals, if they come to the system and they see, for instance, waiting time is too much, or like they're not satisfied with using either of the restroom type, they may be. So in that case, the measurement of the inclusivity is that what is the range of people that actually would use the system. And then we show that once you have unisex restroom, you can cover more individual types and preferences that will actually eventually use your system. And for that reason, having all 3 types of restroom increases the inclusivity of your design. So to recap the results, what I presented today is that we measure safety into a queuing system, and also what we show is that we measure the performance of the system both from efficiency and fairness standpoint. And we show that by a little bit flexibility, you will be a fully flexible system, and also we provide an algorithm that can calculate the number of restrooms that practitioners need to provide in order to provide Potty Parity. And also, in the paper, you can find more results and insights about the adoption of unisex restroom. And thank you very much for listening to the talk, and the paper is available online.